Progressive supranuclear palsy, or PSP, is a neurodegenerative movement disorder characterized by impaired ocular movement in range of motion and speed. PSP affects 1 in every 100,000 Americans every year and is often misdiagnosed as Parkinson's disease. Currently, it is diagnosed on a scale of 0 to 4 by physicians using slow and rapid eye movement tests. During these tests, patients are instructed to follow a moving object held by the physician as it moves across their full field of vision. During this time, the physician looks carefully for any impairments in eye motion. This process is subjective and brings about problems such as biased diagnosis and inadequate treatment prescriptions. For example, a physician in San Diego may diagnose the same patient differently than a physician in New York. As such, we have developed a computerized and objective way of diagnosing PSP using eye tracking software.
We wanted to develop a device that would be able to remove the subjectivity from the diagnosis process and also be able to quantitatively detect the early stages of PSP. In order to do this, it was very important that we develop a test that was quick and comfortable for both patients and administering clinicians, and it was also very important that we keep the price tag below $200 in order to reach the largest amount of people. In our setup, we use the platform to raise the laptop to the user's eye level. We then place the iTribe, an infrared eye tracker, at the bottom of the screen. The iTribe is able to track the user's gaze on the screen and output X, Y coordinates with a timestamp.
We interface with the eye tracker software in Java so we could extract the data as well as run a virtual eye test synced with data collection. We chose to replicate a physician's fast saccade test with a simple animation of a dot flashing across the screen. A user can start the test, save the data, and view the graphs of the horizontal and vertical saccades through their simple graphical user interface. Our next step was post-processing, which we did in MATLAB. We first filtered the data using a logic-based filter, which removes most of the spikes and outliers, and then we used a Butterworth filter, which further smooths the data. From this filtered data, we could calculate velocity, amplitude, and latency, as well as output a score between 0 to 4, corresponding to the official PSP rating scale, as well as an associated percent confidence.
By being able to calculate 3 parameters that our physicians originally wanted us to, range of motion, velocity, and latency, we're able to accurately diagnose progressive supranuclear palsy. Moreover, our system has further implications in fields ranging from behavioral neuroscience to neurobiology. For example, in depression patients, there might be an increase in latency and decrease in velocity. Further studies would need to be done, however, and that's the beauty of our product. Our product is cheap and efficient, allowing for clinics everywhere to have our system and see the effect of disorders on eye movement.